Alright, so we're going to look at how we can build an equilateral triangle just using a compass and a straight edge. So this is not a typical compass that people are probably used to seeing. This one is, I think, a lot easier to deal with and use. I'm going to start just by creating a segment of some sort. I didn't pre-measure it or anything like that. I wasn't paying special attention to its length. I'm going to call this A, I'm going to call that B for no particular reason other than I just need to label them to make it easier to talk about. I want to create an equilateral triangle. What we need to remember about an equilateral triangle is it's also equal angular, and that's actually more of a result than a definition. Like, it's going to end up being equal angular because we created the equilateral, not and the opposite is true as well. But we can use one of those facts to force the other one to occur. So how do we do that? Well, if we can build a triangle with three sides that are equal, then we know the angles themselves will be equal angular, right? So how do we build this segment AC and this segment BC that are the same length as AB? And we can measure this out, and then we can say, well, it goes about that way, right? And we can measure this one, and it goes about that way. But we're going to get stuck pretty fast. So what I'm going to do is I'm actually going to do this. I'm going to measure this out using my compass, and I'm going to use the crosshairs here over A, and I'm going to use this point right here over B. And I'm just going to place that over A. I'm going to place that over B, and then I'm going to go somewhere above this. I'm just going to draw a circle, or part of a circle like that. And the idea behind a circle is that all points on a circle are equal distance from the center of the circle. So I'm making A the center of the circle, and then I just drew part of the circle. I'm going to do the same thing from B. Now if you notice, I put my crosshairs on B, and right there's the point for A. So this time I'm going to hold this in place, right on top of B. Where's my crosshairs there? And then I'm going to go somewhere above here. I'm going to draw that. Now you notice I get this intersection point. Now if I were to draw on this above and below, I could draw a line, and now I have a perpendicular to that spot, which would be useful in its own way. But what I now have is I actually have spot C, because now this distance from A to C here is the same as the distance from A to B, because I used a radius of congruent circles to create those two spots. Now it may not look like this, but I can actually try to measure this as best we can here. And I don't know how well you can see that, but that worked out to be just around 5 centimeters. That is about 5 centimeters and 5 centimeters. Another way I could do that is I could just get a little scrap of paper here. There it is. I'm just going to mark it there. And then I do that again, and yep, that works, and that works. They're all in the same spot. Now that may be off because, of course, nothing can be perfect when we're drawing things, but this is pretty close. So this does actually work out to be equilateral. Now, how do we know it's equal angular? Meaning all three of these angles are the same, and since this is a triangle, all three of them would have to add 180, and if they're all the same, that means they're each 60. So I can put my protractor down here, and I can put the crosshairs over A. I can line up the bottom of the protractor on AB, and when I do that, if I can get it lined up right, you see that there's the angle right there, 60 degrees. I don't know how well you can see that in this image. So that's 60 degrees. I can do the same thing over here. I can line up my crosshairs over there on top of B, and I can get all that. And this time, you can see right here, it says 60 degrees or 120. So this angle is 60 degrees. And then we can do it for this last one here. If I can get the crosshairs over there, right there, there we are. So that crosshairs is directly over that spot, and there's 60 degrees in. So once again, I have that these are 60 degrees. I'm not going to label the top one because I'm going to do something else with it here in a second. But what I now have is a equilateral triangle, which also happens to be equal angular. Now, this is a kind of a neat place where we can do some other stuff. I'm going to find this is 60 degrees, right? So I'm going to find the angle bisector of C. Now, how do we find the angle bisector? Well, what I'm going to do is I just need to make some mark in the middle of angle C somewhere that's equal distance away. So I don't even have to move anything at this point, right? So I already have that C to B is the same as C to A. And that's really the only thing I need. Like if I'm going to do an angle bisector, I would create this angle. I'd mark 2 spots on the angle that are the same distance away from the vertex, which I already have as A and B. But if I didn't have these, I would just simply, I could make this line, I could extend it out as far as I wanted to, right? And I'm going to do this as for demonstration purposes just to show that it does actually work this way, right? And then I can go C in some distance away. I'm just going to go over to here somewhere, all right? Right there and there. Now these two are the same distance away, and I can call them D and E if I want, right? And now all I got to do is go somewhere in between, somewhere in the middle of this. So let's just say here, maybe I need to go a little bit further, huh? Make it bigger. And then do the same thing over here. And now, if I draw from C to that intersection point I created with those 2 arcs, this should be 30 degrees, as should this, right? And we can get our protractor out, and we don't actually have to measure this one though. We can actually measure this one, because watch what happens when we do this. That works out to be exactly 90 degrees there. So if this is 90, that's 60, that has to be 30. If this is 90, this is 90, and that's 60, and that has to be 30. So we actually found that this angle bisector does in fact split this angle in half by 30, and we didn't even measure it. What we did is we ended up creating a perpendicular bisector. Why did this end up being a perpendicular bisector when what we were doing is creating an angle bisector? It was an angle bisector because we were splitting this angle in half. But this particular angle was 60 degrees, and it was 60 degrees of an equilateral triangle, which means all the sides were the same length. Which means that when we did that, we split this into 30 and this into 60, which means that this last angle had to be 90, which meant that this had to be the perpendicular bisector. Now if you're like, is that really the perpendicular bisector? Yeah, it absolutely is. Let me show you. I'm going to extend this line out the other direction that way. And I'm doing that because the way to find an angle bisector is to pick 2 points that are equal distance away from the point, right? And I'm going to draw here. I'm going to draw there. There it is right there, crossing through. I could be a little bit more precise with the way I'm drawing that, I guess. And do the same thing above here, right? Right there. And there. And there it's crossing through again right there. So that's the process of how you find or build the angle bisector, is by drawing those lines, those little crosshairs like I did. I have an entire video on how to do that in a little bit more detail if you want. But there are those pieces. So this is actually the angle bisector, which means this one is now congruent to that one, like that. All right, so it's how to do an angle bisector, and that's how to build an equilateral triangle. The primary idea that we're using here is that we're using a radius of constant length, and you can do all sorts of different constructions just simply by using this idea of equal distance away. It's actually a fundamental aspect of how we build our geometry and use geometry in general. All right, I hope this was useful and helpful, and I hope it's encouraging. Have a great day.